Hello, today we'll be analyzing 4 different microcontrollers. The first 3 belong to the same family, the ESP32. This microcontroller has been very popular and it improves many things over Arduino. And the fourth microcontroller that we are going to analyze is the ESP32S3, which is the newest and fastest version. I have all of them here. First 3 ESP32, fourth one ESP32S3. For this, we're going to use this electronics microscope with 100 times magnification. This thing outputs HDMI signal, and with this capture card, we're going to see it here in all its beauty. So, the first microcontroller that we're going to analyze is the ESP32. This has been a contendant to Arduino, and it has Wi-Fi and Bluetooth, which is very useful. And this breakout board acts as a development board because it has many components here that give them functionalities needed to programming and debugging. The most important part is, and the main difference with Arduino, is this microcontroller doesn't work with 5 volts. It would burn with 5 volts. So you take the 5 volts that the USB gives you and you lower them down to 3.3 volts. This is a disadvantage, but once you start to love the wireless capabilities of this device, that is no problem at all. Another thing with these microcontrollers, as with many others, is that it does not have USB. You have to convert the internal TTL serial port, also known as UART. You have to convert it with this chip to USB. With that, you can communicate your PC with the ESP32. And finally, you have these 2 buttons, boot and enable, this works as reset. These buttons are pulled up buttons that you use to program and reset the device. So, remember, USB gives you 5 volts. The ESP32 requires 3.3 volts. So you have to use a buck regulator. And then, serial converter, USB to TTL/UART. These voltages can be 3.3 or 5 volts. This device is somehow tolerant to 5 volts, but you should always, if you can, you should use 3.3. And remember the push buttons that are pulled up. You don't remember what a pull-up is? A pull-up is a resistor connected to the input of the controller that, by default, sets this voltage to high level. When you press the button, you momentarily lower it down to 0. If you do not use this, you don't know what the voltage is when you unpress the button. So remember, pull up if you want a 1 here by default. You look at this beauty. I'm going to use the same layout. Okay, I'm going to put the antenna on the left. So this is your trace antenna, beautifully made. These are, this is the electromagnetic shield that covers the microcontroller, memory, and quartz oscillator. These are the fine pitch pins that are SMD soldered to the development board, and these are the standard 0.1 inches DuPont pins. Okay, we have here 3.3 volts input, enable, I don't know, positive and negative USB maybe. And these are not pin numbers, okay? These are input or output numbers. Okay, pin numbers are like this, go like this, 1, 2, 3, 4, but input numbers are the numbers that you use when you code your program, okay? So if you code input number 32, you code this input, okay? Sometimes it says IO 32. Okay, let's go up a little bit. Oh, what is this? Okay, I'll give you a small clue. 3 pins and heatsink. 3 pins and heatsink means almost inevitably voltage regulator, okay? Usually the second pin goes to ground and it's also used, it is connected to the heatsink and it is used to heat dissipation. If you look this up on Google, you have here that it is a low dropout linear regulator, okay? Probably it is the 3.3 volt version because it is the voltage that you need to power up the ESP32. Okay. If we go to the left, to the right, we have this square-shaped chip. Okay, CP2102. Okay, classic USB to word bridge. This is a very popular converter. Okay, you have on one side you have a USB, and on the other side you have TTL serial port or word. Okay. Okay, let's move to the right. You have your micro USB Type B. This version does not come with Type C. And we have the enable push button and the boot push button. Both of them with pull-up resistors, which I cannot see here. Okay, I don't know. This is probably an LED. Let me. Yes, I'm sure it is. This is an LED. And many filtering capacitors and resistors. Okay, these two are transistors. And that's it. That was the first board. Okay, this is the second board that we're going to use. You can see this is a very basic board and very cheap. It is a simple breakout board to convert the fine pitch pins to standard DuPont pins. These kind of boards usually don't have any electronics, but well, this comes with pull-up resistors and push buttons for the reset and boot operations. And it also comes with a breakout here for the serial port, so you can identify it in an easier way. It is also here, I believe. Okay, yes, TX and RX. If you use these kind of boards, you need a computer with TTL, but well, they don't exist. Okay, so you need a converter. This is the same microchip that you saw before in the development board. It is also sold in this kind of board that connects on one side to the PC, on the other side to your microcontroller. So let's move on to the microscope. Okay, we start on the top. We start here. Okay, this is the ESP32. On the left, you have the push buttons and resistors. These are THT resistors. You have 3 pins here for programming your serial port, and you have all the rest. You can see the traces. Sorry, let me focus. Now you can see here all the traces ready to connect to a breadboard. Well, this is the other board, okay. USB Type A, male connector, CP2102, no silk screen, okay, so this is probably a copy. And then you have your classic transmission LEDs and reception LEDs with their resistors. Okay, 1, 2. This is not 152 ohms, okay? This is rather 15 with 2 zeros, okay? So 1500 ohms. Capacitor here, and the pins that go to the board, to the ESP board, okay? Okay, now, third board. Well, the third board is quite a monster. It has many components here. It even has a battery compartment at the back. Well, one thing that it has different from the others is that the ESP32 is not a monolithic version, but rather it comes with separate parts: microcontroller, quartz crystal, antenna, flash memory, PSRAM, and so on. And well, it has also LoRa and GPS connectivity. So let's see it. Okay, let's begin with the antenna. This is not anymore the antenna that you've seen before. This is a trace antenna. Okay, no, sorry. This is not a trace antenna, but a 3D antenna. Okay, you can see here. Then you have the ESP32. The first time that you really see it without the shield. You have probably the quartz crystal. I don't know what it is. Okay. This on the right is the flash memory. This is where your program goes. Okay, this is a non-volatile memory. Okay, and this, since the chip does not have many RAM, this is an external RAM. Okay. You can check the components on Google if you want. Wimbond, and you can see the data sheet. Okay, it's a 32 megabit serial flash memory. Okay, flash means non-volatile, while PSRAM is volatile. Okay. Another chip. Okay, let me see. Okay, this is the balancer for the lithium battery. Okay, this thing switches between external USB power and lithium, the battery power. You have here your micro USB port. I didn't see the TTL converter, but it must be nearby. Okay, some push buttons here, power. This is connected to input-output 32. Remember, not pin 32, but input-output 32. Reset. This is a LoRa radio soldered on top of the motherboard. Antenna connector. And GPS module. Okay, here you have it. Same module, different format. And this is a small battery that you use to keep the coordinates of the GPS fixed. And that's it. This board also comes with an LCD display. So that, well, I didn't put it because it would go here. And well, the main disadvantage of these boards is that you probably will not be able to use the pins because they have so many peripherals inside that the pins are already all of them used, or almost all of them used. Okay. Let's move to the fourth board. Okay. The fourth board is the newer ESP32S3, which, well, changes some things. Okay, it is a Well, it appears a simple design, but it is not a simple design, okay? This PCB has 4 layers, 4 different layers. So let's see what we have here. Okay, I'm going to use the same orientation. So we will start with the Type-C connector. You can see it has many pins. We have the reset and boot push buttons. This here is an RGB LED, probably a voltage regulator, I don't know. I'm going to change the angle. Okay, J2WD. Yes. It is the voltage regulator, okay? You have here the IC ESP32 S3. This is the fastest. You cannot see here any USB converters because this microcontroller comes with native USB, okay? They are connected directly to your computer. And this red component is an SFD antenna, okay? The antenna is not a trace, but an SFD component in this case. So that's it. You have seen several PCBs of popular microcontrollers. I hope you liked it, and click that subscribe button.